Welcome back to Microeconomics. I'm Keith Yakucha. In this video, we're going to be going through the basics of supply and demand, the competitive equilibriums. So we're going to start off by introducing demand. We'll go through some of the determinants of demand. We've gone through a bit of demand in some of the previous videos. So if you've been watching some of those previous videos, then this isn't a new topic. We'll then go and take a look at supply. This will be new, and we'll see where this market supply comes from. We'll also talk about the determinants of supply, quickly introduce the concept of elasticity for supply. We'll then bring the two together, evaluate equilibrium, adjustment from a disequilibrium to the equilibrium, and we'll take a look at, in this competitive equilibrium situation, profit as an entry and exit condition and how that works all together. So let's jump over and start off by taking a look at this idea of demand. Okay, so to start us off is to take a look at demand and where this idea of our demand comes from. By far and large, we're going to be going into a lot more detail with this than I'm really interested in you knowing. However, this is vital detail for anybody going on in economics to higher levels as to a way to think about, well, where this demand curve comes from. At the very least, well, we need to know what we've already seen with demand. This is here as that extra background information. So let's get started and take a look at that. So boom, here we go. We have on the left-hand side, we have our budget constraint. That is the white line showing us, given the limited resources, given our budget, the money that we have, all the different possible combinations of scones and coffee which we could buy, given the current price of coffee and the current price of scones and our income. Our goal as a consumer is to maximize our utility, get to the highest level of satisfaction that we can. What we have shown here are three different indifference curves. The indifference curves are showing us, for some indifference curves, all the different possible combinations of scones and coffee, such that I have the same amount of happiness. I am willing to give up some amount of coffee for some number of scones, and I would be just as happy in that scenario. So each indifference curve is the same level of happiness. I'm indifferent between coffee and scones everywhere along a given curve. The higher a curve is out to the right, the happier I am. The lower a curve is down to the left, the less happy, maybe even the sadder that I am. Our goal then would be to obtain the highest indifference curve that we can, given our income, given our budget. And so, given the constraints, the current price of scones, the current price of coffee, we could, given our income, get to some point right here such that our indifference curve is just touching our budget constraint. And we would get a consumption bundle such that it yields us this quantity of coffee. I'll call that Q naught coffee. And this quantity of scones, we'll call that Q naught scones. And what I want you to keep in mind is this is for some initial price. So that is some initial price of coffee and also some initial price of scones. So that's where we're at. What we could then do is we could take our personal decision as to how much coffee, how many scones to consume, and translate that over to here. Because in this case, price is kind of taking place behind the scenes. It's influencing how much coffee I could consume if I were to put all my budget towards coffee, but it's not explicitly referenced on this left-hand diagram. So let's say that P naught coffee is somewhere right around here, P naught coffee, and that would give us, if we just drag that across, where that P naught coffee is, and we see that, hey, we are consuming, based off of just utility maximizing, we are consuming Q naught coffee. So let's just say that Q naught coffee is somewhere like this. Okay. So now we are obtaining this combination of price and quantity for coffee, and we find that we would be right there all together. So that is our current combination of price and quantity demanded of coffee such that we are obtaining the highest indifference curve that we can. Well, the question then is, let's just scroll down a little bit so we can have a bit of room. There we go. The question is, what happens if the price of coffee, we move to P1 coffee, such that the price of coffee were to fall? So we now have a lower price of coffee. Well, okay, let's denote that over here on this, what we're building as our demand diagram. So there's our P1 of coffee. That would be some point all the way across as such. Then the question is, what does that do over on this side? Well, if we have that new lower price of coffee, if I were to just be buying coffee, I could be buying more cups of coffee, all else equal. I could be devoting more of my income towards coffee and buy more cups of coffee altogether. What would happen to my scones? Nothing. The amount of scones that I could buy if I put all my money to scones is unchanged because the price of scones is unchanged. The only thing that has changed is the price of coffee. So the result of that is, let's use the straight line tool. And actually, let's not just use the straight line tool. Let's change the color a little bit. There we go. Let's go to yellow. And there we go. We would get some new budget constraint such that if I were to put all my money towards coffee, I could now get this higher level of coffee altogether. What we see, let's make this new indifference curve pop a little bit more. Let's make it brighter. There we go, to say, hey, this is now the one that we're on. It's not just in the background anymore. We would find that we would be somewhere like this, such that we are just touching that new higher indifference curve. That would give us as our overall effect some new point. Again, let's just keep using yellow. There we go. There would be our new quantity of coffee that we buy. And in this case here, we're doing about the same for our scones, just the way that I've drawn this. We can see why that's the case in a second. So that gives us our new Q1 of coffee, such that our quantity of coffee has increased as price has fallen. So we've witnessed price of coffee has gone down. As a result, our quantity demanded has gone up. This is what we refer to as our law of demand, that price and quantity demanded are inversely related. They move in opposite directions. We would similarly expect that if the price of coffee were to have gone up, our quantity demanded of coffee would have gone down. Okay, how do we see this law of demand? This is the law of demand. Maybe let's move this over to our demand side so that's a bit clearer. How does that translate? Well, what that translates to is, like we said, we have this new higher quantity demanded of coffee. So this is our new Q1, the amount of coffee that we want at P1. So that is, we find ourselves now at this point here. P1, Q1 combination. There we go. That is our new point that we find ourselves at. If we just were to connect the dots between these, let's go something like this. There we go. Connecting those dots, we get this downward sloping relationship, this inverse relationship between P and Q, such that we see our law of demand all the way across. As price went down, our quantity demanded went up. If we went the other way, if prices rose from P1 to P0, we would expect our quantity demanded to fall. Now, one of the things we need to keep in mind, first of all, this is our individual demand curve because it was based off of our individual indifference curves. We cannot find a group utility or a group indifference curve between scones and coffee. This is unique to each individual and cannot be aggregated across individuals. So all we've done is we found an individual demand curve. To create a market demand curve, we'll have to aggregate up all of these individual demand curves, and we'll take a look at that in a few minutes. Well, what I want to do first, and for the majority of you, this here, what we'd call our overall effect, as we just move from point A to point B, giving us point A to point B, is sufficient for what we're going through. For the handful of you who may want to continue on to higher levels of economics, it's important to recognize that this change in price causing this change in Q can be decomposed into both an income and a substitution effect. Actually, let's write this a little bit differently here. There we go. An income effect and a substitution effect. And let's talk about what those look like. So the first one, let's look at the income effect. The idea is, well, hey, we're buying more cups of coffee because cups of coffee are cheaper. Altogether, because cups of coffee are cheaper, we're able to buy more of everything. Our budget constraint has rotated outwards. This is everywhere along this point, we're capable of having more coffee and more scones, with the exception of that one intercept right there. That is, as the price went down, this has made us feel as if our income has gone up. Well, if your income has gone up, what would you want to do? Would you want to buy more things or fewer things? Typically speaking, if the income rises, you want more things. So our quantities go up. So the question that we then ask is, hey, what if we could obtain this this indifference curve? What if we could get to this indifference curve not due to a change in prices, but just due to having more money, right? We had this current budget constraint, given our current budget, our current income. What if we could just get up to a higher indifference curve just by having more money? And so to do that, what we would do is we would just take our existing budget constraints. Sorry, I'm getting excited, getting ahead of myself, getting tongue twisted. Let's go and just copy paste that so we have the same slope all together. And we see if we just kind of bring that out, parallel line, bring that out to the right. Let's make it a dotted line. There we go. So we bring that out to the right. What we see is that if we just were able to get to this higher indifference curve due to higher incomes, not due to changing prices, well, we would actually find ourselves, let's use a different color here, let's use green. We would find ourselves at a point somewhere around there. Again, let's use green and not a dotted line. There we go. Somewhere around there. And we can call that point C. So if we were able to get here just strictly due to higher incomes, we wouldn't get to this overall effect. We would get to C, which would be some point like this, such that higher income means more scones, higher income means more coffee. So through our income effect, we would increase our cups of coffee consumed, and we would also increase the number of scones that we have all together. So there we go. Income up, quantities up. This is what we typically expect to witness. Okay, what we can then do is say, well, okay, cool, that's what we would do if we just had more money. The reality of the situation, though, is that the only reason we're on this indifference curve isn't because we're richer, but because prices changed. Let's change colors to deal with our substitution effect. Let's use this teal color. Why not? That is, what has happened is we have had prices change such that prices of coffee have gone down, but prices of scones have been unchanged. That is, between these two goods, coffee looks relatively cheap compared to where it was before, but scones are now looking relatively expensive. So the big idea here is that you would want to substitute towards the one that looks cheaper, the one that, hey, is giving you more utility, more happiness per dollar spent. So you would want to increase the amount of coffee you want altogether. So you would increase your quantity of coffee, but keep in mind you are bounded by your budget constraint, your feasibility set. So if you want more coffee, you have to go through your marginal rate of transformation. And to get more coffee, you have to give up scones. And so you begin to substitute between the two, substitute towards the cheaper of the two goods. And this substitution effect is what finally brings us from C to B. And C to B altogether for coffee. And we see that as we substitute with scones, C to B, that we just end up in this case, and I want to be clear, in this case, we end up substituting right back to the original amount of scones that we were consuming. And that is just due to the shape of our indifference curve in this scenario. So that is to decompose this inverse relationship between P and Q. This change in quantity, so I guess change in quantity, I should be a little bit clear. This is this change in quantity altogether. That is decomposed ultimately into its income effect, which would be our A to C, and then our substitution effect, which is our C to B. The other way to think about it is as we go from A to C, the reality is that our marginal rate of substitution, that's off of our indifference curve, is greater than our marginal rate of transformation. We would be willing to give up scones for coffee at a higher rate than what we have to give up scones for coffee for. As a result, we give up scones for coffee and we move along that marginal rate of transformation. We move along our marginal rate of substitution until we move from C to B, such that once again, our marginal rate of transformation equals this marginal rate of substitution. So any price change causing that change in quantity can ultimately be decomposed into this income, this substitution effect. Okay, great. For the rest of you who really we just care about this overall effect from A to B, let's get at that part two. That part two being this was an individual demand curve. How do we get from an individual demand curve to a market demand curve? Well, let's clean up and let's take a look at a scenario that explains that. Okay, so boom, here we go. We have a scenario. What are we looking at? Well, what we're looking at is we're looking at some marketplace that has three different types of consumers, three different types of demanders. We have type A, individual type B, and individual type C. For those of you in marketing, this is kind of one of those things that you kind of take a look at where you create these different types of consumers and you can kind of create a bit of a demand structure based off of each one. What we're going to presume is that we have 2 times type A, so 2 people are type A, 2 people are type B, and 5 people are type C. What we want to figure out is, given all of their individual demand curves, what does our market demand curve look like? And what we've done is we've just taken all of our prices for this good and then just dragged them all the way across. To figure out our market demand curve, it's just a case of aggregation. So what we can witness is that at a price of 4, well, type A, nothing. Type B, nothing. Type C, nothing. So at a price of 4, we have nothing. Okay. What happens at a price of 3? Well, at a price of 3, we have 5, but that's times 2. So altogether, that is 10. At a price of 3, we have 2, but again, that's times 2. So that is 4. And then at a price of 3, we have nothing, and times 5, but that's nothing. So we have 0. So at a price of 3, what do we have altogether? We have 10 plus 4 plus 0. That gives us at a price of 3, something like, where would 14 be? Let's say 14 is something like that. There we go. We could say that is 14. And we could begin to connect our line. There we go, something like that. Then we go down to the next point and we say, okay, that was at 3. What is at 2? Well, at 2, individual A, type A, has 10. So 10 times 2, that gives us 1T altogether. Person 2 at $2 has, oh, I didn't draw this one down. Let's update that. Let's say that's 3. So at 2, we have 3. There's 2 of them, so that's 6 altogether. And at 2, we have 10. That is 5 people there, so 5 times 10 is 50. So what do we have altogether? We have 26 plus 50. That gives us 76. So we're having quite a big jump here, all over to 76. Something like that. And that would be down to 76. There we go. Look at that. I changed the color a little bit. Let's bring that back in line. I think I just made it a little bit transparent. There we go. To carry on, where are we at when we're at a price of 1? Well, when we're at a price of 1, we have type A doing 15. There's 2 of them, so that's 30. We have person B at a price of 1 having 4. There's 2 of them, so that's 8. And we have person C, they're doing 20. Well, 20 times 5, that's going to be 100. So we have altogether 30 plus 8 plus 100 is 138. Let's just be, that is 76. We now have 138, and that's going to be at a point right about there. That gives us our demand curve continuing down. Oh, let's, there we go, there's that one. And then continuing down as such. And if we just extrapolate it, we can just keep going. There we go. We get our market demand altogether. For the big chunk of it, it's just linear. Given that I've introduced people where, hey, for person C, they have a much lower reservation price, we do get this little kink in our demand curve as a result, in our market demand curve, as a result, because initially, people A and B are the only ones participating, creating that bit for that first bit, and then we switch following that kink as individual C takes over, which is significant demand thereafter. For any market demand curve that we build, that's all we're doing. We're just taking every individual's demand curve as they equalize, as they find that optimal bundle of goods and services given their indifference curve. As they figure out what that optimal bundle is and get their individual P and Q combinations, we can build their individual demand curves. Once we get their individual demand curves, we can just add them up to get the market demand curve. One of the things that you should be able to see is that if we were to just add more people, say we were to go 5 times people B instead of 2 times, the result of this would be something, and I'm just going to go it generally, we're not going to calculate those numbers, but generally something like this, such that if we had more of a certain type of people, our demand curve would move out to the right. Meanwhile, if we had the opposite case, if we just got rid of B altogether, well, we would have the opposite case happening. We would have fewer, and we would have our demand shifting to the left. Whoops, wrong tool, but let's make it work. There we go. We would have our demand curve shifting to the left in that scenario there because we have fewer people participating in the market. So that is the idea behind our demand curve, the market demand curve, where it comes from. Again, in this case, we're utilizing a kinked demand curve just to show that that does happen due to different types of people with different reservation prices. In our reality, what we will be looking at is just strictly linear demand curves. That is just that downward sloping line portion without the kink. Let's go jump over and take a look at that and take a look at that demand curve altogether and different interpretations of it. Okay, here we have before us a demand curve, and we could say this is the market demand curve for hot dogs. Maybe in this case here, our quantity is in thousands of hot dogs. So we're taking a look at the entirety of the market altogether. And what we see is that at a price of 10, that is the price where people will start to consider buying hot dogs. They're still buying 0. But as soon as the price drops below 10, our quantity demanded starts to increase. At a price of $5, let's say this is our current market price. At a price of $5, people are buying 10. Again, if we think about this in terms of maybe this is thousands of hot dogs, that would be people are buying 10,000 hot dogs at a price of 5 in this market. Our market demand curve is being expressed as price equals 10 minus 0.5 Q. So 10, that is our vertical intercept. 0.5, that is our slope, the rate at which quantity changes for a change in price. Again, slope is just rise over run. So rise over run, change in price, change in quantity. What we can do is for any Q that we witness, we can throw that value of Q into the equation and find the corresponding price. So for example, with what we have here, we can verify that at a quantity of 10,000 hot dogs, we have a price of 5, and that would just be 10 minus 0.5 times our Q of 10. Well, 0.5 of 10 is 5, so price is equal to 10 minus 5, which is, drum roll, $5. So at any point we can witness, hey, what is the quantity demanded? And then go and throw that quantity demanded into the equation to figure out what the corresponding price is. Let's just clean that up, and then I want to talk about that because that's an important distinction. What we've done in that scenario is we've identified some quantity, and then based off of that quantity, determined the price. Never do you do this. You do not walk into Superstore and go to the hot dog aisle and grab 3 hot dogs and then go, okay, because I have 3, the cashier will then charge me a price of this. No, 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 no. In reality, it works the other way. The other way, such that you witness a price of 5, and because there's a price of 5, you then decide how many you're going to purchase. So that is the way that this is expressed, where we witness a quantity and the quantity determines the price. This expression is not actually a demand expression. This is sometimes referred to as an inverse demand. This is truthfully the expression of our maximum willingness to pay, saying what is the highest price I would pay for some quantity. Or the other way we could think about it would be our marginal benefit. What is the extra benefit that I receive from consuming my 10th hot dog? And we see that, hey, we would put a value, an extra value from our 10th hot dog at $5 for that 10th hot dog, which again, that kind of feeds into why that would be the most you'd be willing to pay, because you'd be indifferent between handing over $5 or receiving $5 worth of value or benefit for consuming that 10th hot dog. If we did want to truthfully express this as a demand function, we would have to have it as Q as a function of P. That is, we would want to have Q over here on the left-hand side as our endogenous variable. And we could go around doing that, right? We could go move Q to the left, P to the right. So we would get something like 0.5q equals 10 minus p. Go and continue to isolate q altogether, so divide both sides by 0.5, and we would get q equals 20 minus 2p. This would be our demand equation, such that now it's the reality as to how you deal with things, which is you witness some price of hot dogs and you go, oh, okay, given that price of hot dogs, I'm going to decide to buy this quantity. Given this price, I have this quantity demanded. The problem is, typically we think about a line as y equals mx plus b, such that y is our vertical axis and b is our horizontal axis. If we start expressing demand in this way, which is technically the correct way to express it, we see that q is our horizontal axis and p is our vertical. So it's backwards. Sorry, I just realized I pointed to b as our horizontal. It is x, that's our horizontal. My apologies. So as a result, yes, truthfully, the demand equation is q as a function of p. For our purposes, what we will be working through in our course, just to keep things simple for us, is we will be dealing with inverse demand, or truthfully, with maximum willingness to pay or marginal benefit functions. We will not be explicitly dealing with demand functions. So you don't need to worry about this inverting the function to get a true demand. I just want you to be aware of that difference. Okay, the next thing that we want to take a look at, and we've already evaluated this, but just to quickly remind ourselves of it, is that the slope here, the slope is the change in P for a change in the quantity demanded. Okay, that's nice, saying, okay, if the quantity demanded, if we want an extra unit, how much more or how much less will we be willing to pay for that? What we're often typically interested in, though, is not the slope or the marginal effect, but rather the elasticity of demand, which can be thought of as our percent change in our quantity demanded for some percent change in price. And really what this tells us is how sensitive is our quantity demanded to the price. We saw in the previous videos that this can be also written as just the price over the quantity at some point times 1 over our slope. And that would be the slope of our demand curve. And this would give us our point elasticity. And that would be the elasticity at one specific point on this curve. While this left-hand one here gives us a more intuitive, in my mind, interpretation as to what is happening with elasticity. We can see what the percent change in quantity is versus the percent change in price. Sometimes this right-hand side is much quicker to actually calculate the value of elasticity. I'm not going to go much more into elasticity in this video because we did cover it in depth in a previous one. But let's go and carry on with what I do want to talk about with demand, which is, okay, we have our demand, but is it just always here? Is this just always our demand for hot dogs? And spoiler, no. Sometimes this demand curve is going to dance around. Sometimes we might want more hot dogs. Sometimes we might want fewer hot dogs. Ultimately, we don't have an exhaustive list of what would affect this demand curve and cause it to change, because keep in mind where we got this demand curve from. It was just our budget constraint, our indifference curve, how we obtain that higher indifference curve given our preferences between hot dogs and some other goods. So ultimately, anything that's going to affect that budget constraint scenario is really then going to affect our demand for hot dogs. But that's a rather unclear way to look at it, especially here in an introductory course. So what I want to do is I want to explicitly list out 6 determinants of demand, 6 things that we would want to think about with respect to our demand curve and where it is in this P and Q axes. Keep in mind, this is not an exhaustive list, but it is what we will evaluate when we go through this course as to what it does to impact our demand curve. So let's take a look at these determinants of demand. Okay, so for our determinants of demand, the first one that we have is going to be change in own price. So if the price of hot dogs changes, I want to be clear, this isn't going to change the demand for hot dogs. What it is going to change is our quantity demanded. So it's going to be for the same demand curve, but a different quantity demanded. And this is the most confusing part that people get messed up with. They go, oh, price of hot dogs has fallen, demand has increased. No. Price of hot dogs has risen, demand has decreased. No. What happens in each of those cases is we have a change in our price. So let's go price falls. Let's say price falls to 4. Well, if price falls to 4, the demand has not changed. That is, the curve has not changed. All that has changed is our quantity demanded, such that as price fell, quantity demanded rose. If we went the other way, if price went up, well, in that scenario there, price went up. Same demand curve, we just get a lower quantity demanded. So change in own price does not change the demand curve, it changes our quantities demanded. And that's the first important distinction to be clear about. From here, all of the other determinants of demand, everything below this line, are going to actually affect that demand curve itself. So let's introduce the rest of these and let's talk about what exactly they do. Okay, our next determinant of demand is change in income. So the big thing here is if you become richer, if you get a raise at work, do you want more hot dogs or fewer hot dogs? If you get a raise at work, do you want to have more cars, fewer cars, more toilet paper, fewer toilet paper, more toothpaste, less toothpaste? Right? So the idea here is how does the change in your income ultimately affect your demand for a good or service? And hey, we've already kind of taken a look at this by taking a look at the income effect when we were looking at our budget constraints. Typically, for most goods we would call normal. And for most normal goods, if our income goes up, then our quantity demanded goes up. And here you might be like, wait, Keith, you said everything below this line is a change in the demand curve. And here you're talking again about quantity demanded, just like you were before. Yes, because when we are going through this, anytime we have a change in one of these variables, so a change in income, for example, we have to presume that we have a change in income under the assumption that every other thing is fixed. So that is, we have a change in our income for a fixed price. So what we could do is go back here and say, let's presume that prices are fixed at $5. If prices are fixed at $5, we now have this higher quantity demanded for hot dogs at $5. So we now find ourselves at this P and Q combination. Quantity demanded increased, still at a price of $5. How is that possible? That is possible because we would say our demand curve has increased. And that didn't go through the point. Let me try that again. There we go. Our demand curve has increased. Our demand curve has shifted to the right. And we have our new demand. What is often helpful is anytime we have a shift in demand is to recognize that that old demand curve is no longer there and to kind of blank it out a little bit. so that we can still reference, hey, where it was, because sometimes that can be useful to us, but it's really not relevant to us anymore. Our analysis is now based off of the new demand curve. That is, at this new demand curve, we now find ourselves at a price of 5. So although it's the same price, we now want more than we used to. So our demand for hot dogs would have increased as our incomes increased. That there is under the assumption that hot dogs are a normal good. I bring that up because let's take a look at another possible scenario. The other possible scenario is that we have what we would call an inferior good. An inferior good is a good that you're buying only because you don't have the money to buy something better. And in the case of an inferior good, when your income rises, you actually want less of it. You actually go, okay, cool, I have more money. Now that I have more money, I'm never buying that again. Typical examples of inferior goods would be something like craft dinner. Craft dinner is cheap, so when you have lower incomes, you're buying craft dinner to get cheap pasta, mac and cheese. However, if your incomes were to rise, you'd probably start to buy less craft dinner. You would buy more expensive versions of mac and cheese instead. Quite similarly, it could be argued that hot dogs are inferior. As you make more money, maybe you're not buying hot dogs anymore. Maybe you're now buying fancier smokies. You're buying fancier sausages and the rest. So in this case here, we could presume that as your income went up, if hot dogs were inferior, higher income would be less quantity demanded. Again, less quantity demanded for a fixed price. We would now find ourselves for a fixed price somewhere like that. If we're somewhere like that, what has happened? Well, that is our demand has decreased. Oh, that's not the tool I wanted. There we go. Our demand has decreased. And in this case here, our demand has decreased. Let's update that color. And let's go and shade this guy down to show that it's kind of disappeared. And the impact is less demand at every price level. What I mean is that at every price level, our quantity demanded is lower. And at a price of 5, we now want fewer hot dogs than we did before. So typically most goods are normal. That's why we use the word normal, such that more income, more stuff. But there are certain goods out there that would be inferior, such that if you had more money, you would stop buying it. Your quantity demanded would fall due to you having money to buy fancier things instead. So that's the effect of change in income on our demand curve. Well, let's move on to the next determinant. Okay, our third determinant of demand is going to be change in the price of another good. And that is, right, if we just think about back to that budget constraint, back to figuring out, hey, what bundle am I choosing between scones and coffee, given my budget, given my preferences? If we were looking at our preferences between hot dogs and other goods, and we had a change in the price of hot dogs, well, hey, that's just captured right here in the demand. That's one. But if we had a change in the price of another good, well, hey, that changes the budget constraint. That's going to then have an income and substitution effect for that other good, as well as for hot dogs. And that is, we're going to have some different quantity of hot dogs that we are consuming because the other good changed its price. But keep in mind, while the other good changed its price, from the point of view of this market, we have to hold all of these other determinants fixed. So that is, we're going to say the price of hot dogs is unchanged. It's just the other good that's changed its price. And as a result, we're either going to have a higher or lower quantity demanded of hot dogs. Under the change in price of other goods, we're going to have two possible scenarios. And these two possible scenarios are going to be that these other goods are substitutes, so these would be things you buy instead of hot dogs, or they could be complements. And complements are goods that you buy together. Let's start off by evaluating a change in the price of a substitute. And that is, let's suppose that the price of sausage falls. And we'll presume that sausage is a substitute to hot dogs. Seems reasonable. You know what? Maybe smoky. Maybe a smoky is a better substitute. So price of smokies falls. Okay, so if smokies are cheaper, law of demand, our quantity demanded for smokies has risen. What has happened to hot dogs? Price of hot dogs is unchanged. But what happens to our quantity demanded quantity demanded of hot dogs? Well, if we're buying more smokies for a fixed income, the only way that we can buy more smokies is by giving up hot dogs. And so for a fixed price, we are substituting away from hot dogs towards the cheaper smokies. The result of that is for a fixed price, we would now find ourselves somewhere here, lower quantity demanded altogether. There we go, lower quantity demanded. And the result of that would be change in the price of smokies has shifted our demand curve to the left. We now have less demand at every price level. Our quantity demanded has fallen at every price level. So change in the price of a substitute will change how we substitute between that other good and this good. Of course, if price of smokies had gone up, making smokies more expensive, well, law of demand, we would have wanted fewer smokies. If we wanted fewer smokies, we probably would have had more hot dogs. Demand would have increased in that scenario. Let's talk about complements next. Okay, in the case of complements, these are goods you buy together. So let's talk about hot dog buns, right? Typically, you're not just raw dogging a hot dog. You are putting that hot dog in the hot dog bun and eating them together. So there's going to be some ratio of hot dogs and hot dog buns that you tend to buy together. But what happens if the price of hot dog buns, HDB, hot dog buns, goes down? Let's go down this case. Let's say that hot dog buns become cheaper. Well, if hot dog buns become cheaper, law of demand, you are going to consider buying more hot dog buns. What's happening to the price of our hot dogs? Price of our hot dogs is entirely unchanged, right? Because we have to hold these determinants fixed. But hey, if I'm buying more hot dog buns, I'm not just buying more hot dog buns to eat on their own. The reason I'm buying a hot dog bun is to put a hot dog inside of. So, although the price of hot dogs is unchanged, I will be buying more hot dogs to go in these more hot dog buns. So the result of this change in the price of a complement, cheaper hot dog buns means more hot dog buns. If I'm buying more hot dog buns, I need more hot dogs to go in those buns. So for a fixed price level, my quantity demanded of hot dogs is now higher. If my quantity demanded of hot dogs is now higher, I'm now somewhere like this. If I'm now somewhere like that, that is because my demand for hot dogs has increased. My demand for hot dogs has shifted to the right. Of course, the opposite would also be the case. If the price of our hot dogs increased, if the price of our hot dog buns were to increase, hot dog buns were getting more expensive, we'd want fewer hot dog buns. If we're buying fewer hot dog buns, well, we don't need as many hot dogs to go in fewer hot dog buns, so we would also be buying fewer hot dogs. So completely symmetric would go in either direction in that case there. Okay, let's carry on. Let's take a look at our next determinant of demand. Okay, our fourth determinant of demand is just a change in our tastes, our preferences, or our expectations. Essentially, what you can imagine is this is a change to our indifference curve, the level of utility we get from hot dogs. And we could look at a few different possible ways that we could talk through this. Your tastes, your preferences for hot dogs. Let's say that there's a new news article that says, hey, hot dogs are found to cause cancer. and all of a sudden you have this new bit of information. You're like, oh no, hot dogs increase my chance of getting cancer. That's not great. I don't like cancer. Well, if I don't want cancer, the result is that this news, this new bit of information is going to change my tastes, change my preferences towards hot dogs, such that I'm going to want to have fewer hot dogs, all else equal. So, for a fixed price level, all of a sudden this new news item has changed my preferences towards hot dogs such that I want fewer. I'm now finding myself there. That is an impact of lower demand. Our demand for hot dogs has shifted to the left. It has decreased. Of course, the opposite could also be the case. Maybe we find out that hot dogs are some kind of superfood, and I don't know, the nitrates and all the sodium and everything in those hot dogs turns out to be great for you, gives you like extra energy, makes you be able to run super far and be stronger than you normally would. Maybe those are things that you're like, hey, that's pretty awesome. I want more hot dogs because I'm really buying into this whole concept of a superfood. And as a result, in that case, your tastes and preferences towards hot dogs have increased. Thus, your quantity demanded for a fixed price level increased. Thus, your demand for hot dogs would have also increased. Expectations are another possible one. And we see this a lot in cases, man, we have had a lot of recent history where expectations have influenced demand. We had the scenario back a few years ago, I believe it was somewhere circa 2020, when we had the atmospheric river that shut down the Malahat. As a result, we had no gas, no fuel being delivered for a few days to the South Island. Because of that, people expected that they would not be able to get gas in the future. And so what did they do? They wanted that fuel today to ensure that they could have it because they had this expectation that they wouldn't be able to get fuel. Instead of waiting the few days to get the fuel, they went to get it now. The result of that is it pushed up the quantity demanded of gasoline for the current price of gasoline. The result of that, we had a surge, we had a huge increase in the demand of gas for that fixed price level. All of a sudden, the result was because we expected a shortage of gas, we surged our demand for gas, which actually created a shortage of gas. Over the pandemic, we had a similar kind of result. We thought that we weren't going to be able to get toilet paper because we thought we weren't going to be able to get toilet paper. And we're like, hey, we want toilet paper. That resulted in people surging their demand for toilet paper today instead of waiting and buying that toilet paper in the future. And as a result of that, for a fixed price, demand for toilet paper surged. And given a fixed, what we're going to get to later, supply, we ran out of toilet paper and we had shortages in that case. So often, just based off of what you expect to happen, if you expect something to happen, you can manifest that today. By manifesting that today, you influence your quantity demanded and thus shift that curve correspondingly. Okay, let's move on to the next one. Okay, our fifth determinant of demand is just seasonality. And what we see is that there are certain seasonal trends in our demand. For example, if we were to continue talking about hot dogs, in the summer, people like to roast hot dogs over an open fire. So in the summer, what we would typically tend to witness is that the quantity demanded for a fixed price level would rise. Thus, our demand curve would shift to the right. As we move into the fall, as we move into the winter, people aren't wanting to be outside as much. They're not roasting these hot dogs over an open fire. So they don't have this same kind of need or desire for hot dogs. So just due to this seasonal change, our quantity demanded for hot dogs begins to fall, and thus the demand for hot dogs would shift to the left. We see seasonality in other ways, as if we're talking about the demand for ice cream, as all of a sudden we get hot weather, people all of a sudden want ice cream. Demand for ice cream surges because of the seasonal change towards hot weather. If it gets cold out, we get into the winter, Typically, people don't want as much ice cream anymore, so the quantity demanded falls, the demand shifts to the left. We come up to Halloween. All of a sudden, in preparation for Halloween, the demand for candy increases. We come up to the holiday season. The demand for gifts, presents, all of that cheap little trinkets and stuff, all of that demand increases. So we see certain seasonal trends such that as we have these recurring seasonal changes in weather, these seasonal changes in just our holidays, our festivities, demand moves with that and either increases or decreases as a result. Really, the reason why this is because we have seasonal tastes and preferences, which change as a result, but we're just separating it out to be a bit more explicit in that case. Well, let's go take a look at our final determinant and one that we've actually already evaluated in building this demand curve. Our final determinant of demand is population. And because we built this market demand curve just by aggregating up the individual demand curves, well, the bigger the population, the bigger the demand. So as population grows, demand shifts out to the right. As population shrinks, we're having fewer people whose individual demand we're adding up, so demand shifts to the left. So as our population changes, so does our demand. What I want you to take away is, well, the first one, change in own price, just changed prices, and then as a result gave us a new quantity demanded. These next 5, these all resulted in a change in the demand curve itself. And what I want us to keep in mind is anytime we're changing anything, we have to change only one of these while holding all the others fixed. And I kept explicitly referencing that every time we said, hey, a change in income, a change in the price of something else, a change in taste, preferences, expectations, seasonality, population. We're saying, hey, let's presume that prices are fixed at $5 for that fixed price level. Do we want higher quantities or lower quantities? The result of that, the entire demand either shifting higher to the right or shifting lower to the left. Great. That is our demand side. Let's carry on from here. Let's go jump over. Let's take a look at our supply side of the whole situation. And to do so, what we're going to have to do is take that step back into our previous chapter, into firms and their customers, taking a look at our cost curves. And what I want to be clear is we're looking at that unique situation where firms are very competitive, where firms are entirely a price taker. And let's go look at that and talk about what exactly that means. So this is a commonly overlooked point with our supply curve, is that in order to get a supply curve to relate to our demand curve and figure out a competitive equilibrium, we actually need to have a competitive market where we have many different firms all producing the same thing. The result of that is that we need these firms to be price takers. And so in this situation, what we're talking about is a case where maybe we have a bunch of bakers all making cookies. But from the view of the consumer, from the view of you and I, there is no difference between these cookies. They're all just chocolate chip cookies. We don't see one of them as being worth more or worth less than another. This is a case where you have lots of different apple orchardists all growing apples. And again, you don't see any difference between the apples from one orchardist from a different orchardist. This would be a case where you have a bunch of different farmers all growing broccoli. And again, you don't see the difference in the broccoli from the one farmer from the other. A bunch of different just plain white t-shirts. You don't see a difference between the t-shirt from one company from the other. This is very important because when we take a look at many goods out there in the world, you do see big differences. You do see that, hey, a t-shirt from this company is different than a t-shirt from a different company. And as a result, because you see those differences, we'd say there's product differentiation, we can't actually look at a supply curve because there isn't a supply. There's just how much that individual company supplies or produces of their good. To take a look at the supply curve itself, we need a bunch of companies that are all competing to sell the same good that you don't see a difference between. We call this all together, we call this perfect competition. Perfect competition. And looking at that, that was terrible writing, but hopefully you get that idea. To work through perfect competition, let's go back to our firm's cost curves and evaluate what's happening. So in this case here, we have our vertical axes, that is our price or our costs. Ultimately, both of those, we could say that is our unit of account, we'll say dollars. On the horizontal axes, we have our quantities. Of course, we do have our average variable cost. What I'm going to be looking at, though, is really just, let's use blue, our U-shaped average total cost, and then we'll use red, little dip, and then up through the minimum point, we have our marginal cost for this firm. As these firms are price takers, and again, if we can recall, profit maximization occurs where marginal revenue equals marginal cost. What we want to witness is what is the marginal revenue for a variety of different prices. Because, hey, our marginal cost is right there. And what we can do is we can figure out all the different Q stars, all the different optimal amounts of quantity that they produce in order to maximize their profit. Well, in the case where these firms are perfectly competitive, that is where they are price takers, we have this unique situation where from the perspective of the firm, even though the market demand is downward sloping, that is, the market demand for all apples is downward sloping. Let's just take a look at that so we could see. There we go. This is our market demand for apples. Again, this is just dollars. This is just quantity. We get this downward sloping demand curve for apples, such that, hey, if apples are cheaper, you want more apples. If apples are more expensive, you want fewer apples. Well, from the point of view from the firm, they are so focused, so just narrowed in on the one point of this, that from their perspective, all they see, all that firm sees is the current market price. So all the firm sees is this current market price, P, that apples are currently selling at. At this P, the total amount of quantity that is being bought and sold. So right at this P, we get our quantity. Oh, that's the wrong tool. We get our quantity demanded. This firm is so tiny with relation to this market that they couldn't, even if they produced everything they possibly could, that would have such a tiny impact on the total amount of quantity in this market that it wouldn't even register as being an increase in quantity causing a decrease in price. That is how tiny this firm is in relation to this entire market. That is, let's say, right now, and taking a look at our demand for apples, this is being measured in the billions of pounds. And this firm is only capable of producing thousands of pounds. So thousands to billions, inconsequential. It is a drop in the bucket. Similarly, if this firm were to shut down, produce zero, that would be such a tiny decrease in that quantity altogether that's available in this market that, again, it has no impact on that price. It is inconsequential. Thousands to billions is a drop in the bucket. What does this mean? Well, this means that this firm is just entirely our price taker. So they would take this current market price and, hey, look at that. If they're just taking that current market price, This is that special case where from the view of the firm, our demand is perfectly elastic. So this is our one special scenario where price equals marginal revenue. Keep in mind our typical case, marginal revenue has 2 times the slope as our price. Well, 2 times the slope of our price would just be slope of 0, flat line, no slope. So 2 times 0 is 0. We have price and marginal revenue being one and the same. So what we have then, based off of that, is the firm, figures their profit maximizing level of output where marginal revenue equals marginal cost. So marginal revenue equals marginal cost. That takes place right there. They get at that price, they get their corresponding profit maximizing level of output. What happens if the price in this market goes up? Well, if the price in this market goes up, becomes higher, at a higher price altogether, the firm responds, hey, we have a new price, marginal revenue to marginal cost. The firm responds with a higher quantity that they supply. So as prices go up, the quantity being supplied by this individual firm becomes higher and higher and higher and higher. As prices continue to rise, higher and higher and higher prices, the quantity supplied continues to rise. Alternatively, if prices were to fall, well, similarly, falling prices, falling quantities supplied. So what we get from this altogether is our law of supply, such that if the price goes up, our quantity supplied goes up. If prices go down, our quantities supplied go down. That is, we have this positive relationship between prices and quantities. Now you might be confused. You might be saying, hey, Keith, here, prices going up, we are supplying more and more and more. But as prices go up, aren't we clearly demanding less and less and less? Yes, we are. We don't have a requirement these are always one and the same. At higher prices, people don't want as many apples. But at higher prices, firms want to make more apples and sell them at this higher price. It doesn't necessarily mean that all their apples will be able to be sold. It doesn't necessarily mean that at this low price, all the apples we want to buy are able to be produced even. Because as price falls and quantity demanded increases, well, our quantity supplied decreases. So just because we have the amount we want to demand, the amount we want to supply, doesn't mean we'll actually be able to get that. And that's going to be something we'll look at later. Right now, what I want us to take away is that this marginal revenue, marginal cost, giving us our optimal profit maximizing Q star, gives us this positive relationship between P and Q, such that at higher prices, higher quantities supplied. Lower prices, lower quantities supplied. The other thing I want you to take away from this is just taking a look at one firm. This is one firm that is making, in the scheme of things, thousands versus a demand of billions. That is, this one firm is a drop in the bucket. So what we can do is, while we just took a look at this relationship between prices and Q star, or the quantity supplied for a single firm, we would want to go through and figure out what is our market supply altogether. And so let's go jump over, let's take a look at this market supply altogether and see what that would look like and how we could determine that. Okay, boom. Here we have three different types of firms, and we have the number of firms that exist in each case. And again, this would be a case where all of these firms are price takers selling the same good. So these are all bakeries that are price takers, all selling cookies that the consumer sees as the same thing. These are all apple orchardists growing apples that the consumer just sees as the same thing. It should look altogether very familiar to what we're looking at with our demand curve, and really it is that same idea. So what we want to do is take a look and say, okay, at each point, how much is being produced? And based off of that, let's aggregate up and create our market supply curve. So, okay, at our initial price, oh, look at that, I didn't even put prices there. Let's go and say we have a price of, let's say, $2, $4, $6, and $8. There we go. Then let's change my color to red. Okay. At a price of $2, firm A just enters but isn't producing anything, 0. Firm B isn't even considering producing yet, so 0. Firm C, again, just entering, not producing anything, so 0. So altogether in the market at a price of $2, nobody is producing. We have no supply. As we jump up to a price of 4, firm A is able to produce 5 units. What we see is that there are 3 firms that have these similar costs. So 3 times 5 give us 15 units being produced altogether. And again, maybe this is 1,000. Firm B, we have at $4 producing 2. And there's 2 type B firms. So 2 times 2, we have 4 units being produced altogether. And then finally with firm C at a price of $4, we have 10 units being produced. There's 2 of these guys. So that is altogether 20 units being produced in this market. So sorry, by firm C. So that's going to be 15 plus 4 is 19 plus 20 is we can make altogether 39 units at this price of $4. So just connecting that down as such. Okay, carrying on. When firm A is facing a price of $6 a unit, marginal revenue equals marginal cost gives us 10. We have 3 of these guys, so 3 times 10 gives us 30 units. At a marginal revenue of 6, firm B is making 3, so 3 times 2 is 6. And at a marginal revenue of 6, marginal revenue equals marginal cost gives us a Q star of 20. Well, there's 2 firms making 20, so that's altogether 40. What do we get? 40 and 30 is 76. So 39, about that again. There we go. Something right around there. That is our next level altogether. What did I say? 76. Finally, what's happening at a price or a marginal revenue of $8? Well, at a price or marginal revenue of $8, firm A is able to produce 15. Again, there's 3 of these guys, so that is 45 units being produced. Firm type B at a marginal revenue of 8 is making 4, 2 of them, so they're making 8 units altogether. And firm type C, marginal revenue of 8, marginal revenue equals marginal cost, giving us our Q star 25, 2 making 25, so that gives us 50. We get 95, 103. So something right around there, let's say, would be a total quantity supplied of 103. Again, just drag that down so we can see where that is. And what we see is we have this upward sloping relationship between our prices and the total quantity supplied to the market, such that we get a upward sloping curve that looks something like that. I just freehanded it, so it's a bit funny. But we get our upward sloping supply curve. Again, just like with our demand curve, all this supply curve is just an aggregation of all the individual actors in this market. If I had more firm type Cs, well, that would be more of those being produced at each price level. That would be the supply curve shifting to the right. I would have higher amounts being supplied at every price level. Alternatively, if we just altogether got rid of firm type B, that would be less supply at every price level. So that would be our supply curve shifting to the left. So again, just by changing the number of firms that we're aggregating, that we're adding up, we can change that market supply altogether. Great, this gives us our concept of supply and where market supply comes from. A little bit of a quicker process to go through in this case than when we were looking at the demand side. But similarly, let's now take a look at the supply on its own and talk about some of these determinants of supply. Okay, so boom, here's the other side. Here's our supply of hot dogs. We have some notional supply equation for our hot dogs such that price equals 2 plus 2Q. So again, 2 would be that, I guess the first 2 would be that vertical intercept right there. And then the second 2, the slope is positive this time, saying for every plus 1 quantity, the result is we have to increase the price by plus 2. What I want you to keep in mind is that supply, as is presented, would typically be kind of like what we had with our demand, the idea being, hey, for some price, how much would I be supplying? That is the idea being if I had a price of $5, how many hot dogs would I supply altogether? And if we had a price of $5, we would have only one hot dog being supplied in this case. What we can see though is that doesn't come out of the formula again. What we have again in this formula is the other alternative interpretations of supply, which would be our marginal cost. That is, again, the change in total cost or a change in output. And why is it the marginal cost? Well, going back to just how we derived the supply equation, it was just the marginal cost curve for each of those individual firms. So similarly, it's just the total industry marginal cost. The other way to think about it is that it is these firms' minimum willingness to accept. It is the lowest price that they would accept to produce that number of units, to supply that number of units. So the way that we've written this here, price equals 2 plus 2Q, is truthfully written as a minimum willingness to accept or as a marginal cost function. To truthfully write it as a supply function, we would again have to write it as Q equals some function of P. That is, we would have to rearrange it to be, so we would have 2Q equals 2 minus P. We would have negative 2Q equals 2 minus P. Continuing to get that Q by itself, we divide everything by negative 2. So we would get Q equals, well, that's now going to be 2 over negative 2, so that's just going to be negative 1 plus, we have, technically, there's a 1 in front of that, so that's now going to be negative 1 divided by negative 2 plus 1 half P. And that would technically, this would technically be our supply equation, such that at a price of 5, we would get our total quantities. And I see in that I was a little bit sloppy. When I said, hey, our quantity was 1, that was just my poor quick mental math. That is actually that our quantity supplied was 1.5. And again, you can think of these probably as thousands of hot dogs for the market altogether. So 1.5 thousand hot dogs being supplied at a price of $5. Where did I get that from if that's not initially clear? That is, quantity is equal to negative 1 plus 1/2 or 0.5 price of 5. So 0.5 of 5 is 2.5. 2.5 minus 1 or minus 1 plus 2.5 means that we have a quantity supplied of 1.5. And again, if I'm talking about 1.5 thousand hot dogs. So we get our quantity supplied that way. One of the other big things, although we don't deal with it nearly in the same level of detail as we did with demand, is we would also have and are also interested in what we would call our elasticity of supply. And our elasticity of supply is the same idea. It's saying, hey, how sensitive is our quantity supplied? So what is the percent change in our quantity supplied for some percent change in the price? If price changes by a lot, well, do we get a big change in our quantity supplied or a little change in our quantity supplied? So again, just determining our sensitivity to prices. Again, this can be calculated either in this form, or if we were to find the point elasticity, it could again be P times Q times 1 all over our slope. And of course, in this case here, the slope we are referring to would be the slope of our supply curve. And slope of our supply curve in this inverse supply or marginal cost minimum willingness to accept form. Again, although technically Q equals some function of P is the correct interpretation of supply, forget about it. That's not the way we're going to be dealing with supply. We'll deal with it truthfully in its minimum willingness to accept or its marginal cost form. What I want you to take away from that then is 1 over this slope is what we could use for this elasticity of supply. Same kind of outcomes as with elasticity of demand. The bigger this number, greater than 1, the more elastic or the more price sensitive our supply curve is. The smaller this number, between 0 and 1, is the less elastic or inelastic, the less sensitive we are to prices. What determines this elasticity of supply, whether or not the supply curve is elastic, very sensitive to price, or inelastic and not very sensitive to the price, entirely again depends on the degree of substitutes, how available substitutes are. If we're talking about hot dogs, how easy would it be to change your factory to produce other forms of smushed up meat? If you could make different forms of smushed up meat, maybe we're talking about salami, we're talking about Spam, we're talking about different other forms of meat all mushed together instead of into tubes, but into other shapes. If that's really easy to do, then you would have an elastic supply curve, because if the price for hot dogs falls, you would just substitute to those other things you could produce. Similarly, if we were talking about apples, if it was really easy to switch your apple orchard into a cherry orchard, well, if price of apples were to fall, you would just quickly switch to cherries. However, maybe it's not that easy. Maybe, hey, to switch from apples to cherries is years of no activity. And so this is a significant cost to switch. It's a big decision to switch. And so as a result, maybe you're stuck with lower prices of apples if the price of apples falls. So in that latter scenario, if you cannot easily substitute between different forms of production to different types of products, then you're stuck with those prices that the market gives you, and you would be not very price sensitive, or you would be inelastic. So just similar with the elasticity of demand, this depends on how available substitutes are. In this case, we're just talking about your ability to substitute towards producing other goods, given what you're producing altogether. Okay, from here, let's move on and let's talk about, just like we did with our demand, the determinants of our supply curve. Okay, so just like with our demand side, what we start off with is our first determinant, change in own price. So if we have a change in the price of hot dogs such that hot dogs go up in value, up in cost, up in price, well, the result of that is just simply a change in our quantity supplied. Just because price of hot dogs goes up, just because we are able to sell hot dogs for more money, does not mean that our supply of hot dogs increases. No, the supply of hot dogs is constant. The supply is already showing us all different combinations of P and Q, assuming everything else is fixed. So if the price of hot dogs goes up, the only effect of that is A, increase in our quantity supply. Similarly, if the price of hot dogs were to fall, the only impact is a fall in our quantity supplied. So just like with our demand curve, any change in own price is just a movement along the curve. So change in own price, this is just a change in quantity supply, not a change in the supply itself. Okay, let's go take a look at the other ones that are a bit more exciting. Okay, so the first determinant of supply we're going to take a look at is this change in input costs. So the price of the inputs of all your intermediate goods into your production process. So again, if we're making hot dogs, maybe this is the price of energy that you need to power your machines. Maybe this is the cost of the pig parts that you use in making the hot dogs, or the chicken parts, or the beef, the cow parts. As you go through that, if the price of beef goes up, your input costs are going up. If the price of beef goes down, well, your input costs are going down. Maybe this is the cost of your wages, the prices that you need to pay your workers who are grinding up and making these hot dogs. So in this case here, as your input costs change, so does your marginal cost, and thus so does your ability to produce. Again, as we change anything here, we change any of these determinants, all else constant, so we'd be changing the input costs, presuming a fixed price of hot dogs. So that is, price of hot dogs is fixed at $5. If we say, well, like we were just suggesting, let's suppose that the price of beef, which is an input into making beef hot dogs, if the price of beef goes up, what happens to our costs? What happens to our ability to produce hot dogs at this fixed price level? Well, if the price of beef and input cost goes up, then our costs go up. So that is, to produce some quantity, we're going to have a higher cost, but we don't want to think about higher cost, higher price. What that really means is, for a fixed price level, we're able to produce less than we were before. So that is, we now find ourselves at a lower quantity supplied at this fixed price level. That is the effect of our supply curve. That is the effect of our supply curve shifting to the left. And so higher input costs, lower supply, supply shifting to the left. And I want to be clear about that, because we did say, well, hey, technically what's happened is these higher input costs, this price of beef, is that at our existing quantity of hot dogs being produced, we now have a higher cost of production. Our marginal cost is now higher than it used to be. This is true. This is absolutely true. But we're doing it for a fixed price, so we're not looking at this new higher price. The result of this higher cost for this quantity means that at a fixed price, our marginal revenue equals marginal cost is lower quantity supplied altogether, such that as our input costs went up, our quantity supplied, or our supply, fell and shifted to the left. And what I want to be clear, I'm going to refer to shifts in supply entirely shifting to the left, shifting to the right, and I recommend you think about it in the same way. The reason being, we tend to think about left as less, right as more, but we typically also think about up as more, down as less. This is where the potential confusion with supply comes in, because if you think about it as an upward or a downward shift, you would look at this and go, look, supply shifted up. And you would think about that supply up, more supply. No, 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 no. Supply shifted up, which is higher costs, which is less supply. So if you think about it as up and down, it's so easy to get confused. So don't do it. Think about it as shifting left as less, right as more. And in this case here, higher input costs, supply shifts to the left. We have lower quantity supplied or the fixed price level. Of course, if input costs got cheaper, price of beef collapses. Well, our input costs are now lower. We could produce more at every price level. So this would be a great thing. This would be more production, more supply at our fixed price level. Let's carry on and take a look at our next determinant. So the next determinant of supply to take a look at is, then you might be like, wow, I think I've seen this before. You have. This was also one of our determinants of demand, which is change in price of other goods. And again, what we have is, under this, we have two types of goods. We have both substitutes as well as complements. In this case, though, what we're talking about is substitutes and complements of production. Keeping in mind, we have our law of supply such that price up, quantity supplied up, price down, quantity supplied down. Well, let's start off with substitutes. Let's presume that this firm producing hot dogs could also produce sausages. So it's all the same equipment, it's most of the same inputs, different spices and the rest, but they're set up that they could produce either hot dogs or sausages. Well, what would happen if the price of a sausage were to go up? Well, if the price of a sausage were to go up, given our law of supply, the quantity of the sausage would also increase. So given the higher price of a sausage, they would want to make more sausages. Well, what does that mean for what we're looking at, which is hot dogs, price unchanged? Well, if we're making more sausages, that is, we're using our inputs, we're using our machines, we're using our labor, and instead of using all of that to make hot dogs, we're using it to make sausages. So we're substituting away from hot dogs and towards sausages. So as the price of sausages goes up and we make more sausages, we must make fewer hot dogs. The result of that, we end up somewhere like this, at this new lower quantity supplied. That is, we have our supply curve once again shifting to the left, and in this case due to a change in the price of a substitute. Of course, the opposite is also true. If sausages were to become cheaper, we wouldn't want to make as many sausages. If we're not making as many sausages, we can use that equipment to make more hot dogs. Quantity of hot dogs would increase. Okay, let's talk about complements here. To be honest, I'm having a hard time coming up with an example with hot dogs where we have a complement of production. Essentially, what's happening with our complements of production is you're producing one good, and the waste product of that one good can be used and sold as another good. And in this case here, let's talk again about, instead of hot dogs, let's talk about apples. And when you're producing apples, your main good that you are producing is your quantity of apples. But what you can also produce is you can produce apple juice or apple cider. We'll just say those are both the same thing, just different ways to say it. The way that it goes is the apple juice, the apple cider, is typically made from the reject apples. That is, the ones that aren't perfect, the ones that people don't necessarily want to buy. They have a slight blemish in them, they have a bruise, they're not the perfect apples. Those are the ones that get used for apple juice. The result of that is if our quantity of apples goes up, we produce more apples. By default, we're going to have more with blemishes, more that are imperfect. So our quantity of apple juice would go up as well. They're complements of production. The apple juice is the fall off of making apples. Okay, so in that case there, let's say this is our supply of apples instead of our supply of hot dogs. So if this is instead our supply of apples instead of hot dogs, let's suppose that the price of apple juice goes up. Well, the price of apple juice goes up. This is not our supply of apple juice. This is our supply of apples. We will want to supply more. Well, we're talking about supply. That is, we would want to increase our supply of apple juice. Law of supply, right? Positively related. For the price of apples then, unchanged price of apple, the resulting impact would be that, hey, if we're making more apple juice, we would by default then also be making more apple. And so in this case here, because the price of apple juice has gone up, we also want to make more apple to make more apple juice. They go together. They're complementing each other. So in this case, fixed price of apples, that's not changing. They're still $5 per ton per half. The impact is that we're now making more than we were before. So we're now somewhere over here. Higher quantity supplied for a fixed price level. So our supply of apples has increased. That is, our supply of apples has shifted to the right. And that's our impact of a complement of production and the price change of a complement. Let's carry on down our list. The fourth determinant in our determinant of supply is changes in technology or weather. Really, the way that we can think about this is just an exogenous change. Something hits us in our ability to produce things. Because I still have it written as apples, let's start off talking about weather and apples. Suppose we were to have a large hailstorm come through and all the hail comes, hits the apple orchard, bruises all the apples, and destroys a bunch of the crop. Well, the result of that is, well, just because of this freak weather event, for some fixed price of apples, it doesn't really matter what the price of apples is, for where we're at, we just cannot produce as many apples because this weather event just destroyed a whole bunch. The result is our quantity supplied of apples has fallen because of this weather event, and the result would be that our supply shifts to the left because of this destruction of our crop. So this weather destroyed our crop, quantity supplied falls, supply shifts to the left. Of course, we could have a weather event where we have this amazing, perfect growing season, given we've done nothing but just exogenously, something outside of the system has made a perfect growing season. Now we're supplying more apples, all else constant, supply shifts to the right. So it could go both ways. If we were to go back and talk about the hot dogs, we could say something with technology. Maybe we get some new technology that allows us to get some new machines that greatly increases the productivity of our workforce, greatly increases the productivity of the grinding of the meat and stuffing it into tubes. The result of that is this new technology, this increased productivity, has increased the amount that we can supply at a fixed price level. And thus, given that, we would have our supply curve shifting to the right because of this new technology. So typically, technology is viewed as positive. Weather can go one of two ways. Our fifth determinant of supply, just as how we got our market supply curve, and we've already talked about this, is the number of suppliers. If we have more firms making hot dogs, and hot dogs are just entirely price taking, you don't see a difference between one type of hot dog and the next, well, then more firms making hot dogs, we have more supply. If we have fewer firms making hot dogs, we have less supply. So just strictly more suppliers, more supply, fewer suppliers, less supply. As easy as that. Our last determinant of supply, and I've put it in its own color because while its taxes ultimately will affect our supply curve, and we could say taxes or subsidies, I put it in its own color because it truthfully does not change the marginal cost or the willingness to accept of the firm. What this truthfully does is it augments the supply curve such that the market witnesses a change in supply. So for example, if we were to put a tax on this producer, the impact of this tax would be, and let's use yellow again for that, the impact of a tax would be the supply curve moving to the left. And truthfully, the way that that would be visualized would be that the size of the tax is this vertical distance between the two supply curves. That is between the supply and our augmented supply curve. If you were to take this and you were to say, well, okay, there to there, that vertical change in those supply, that would be our tax per unit. That is the rate in which we're saying, hey, every hot dog you sell, because they're so full of salt, which creates heart problems, we're going to charge you 50 cents per hot dog in order to discourage people consuming hot dogs by making it pricier. The impact of that would just be a shift up of that supply curve by that 50 cents per hot dog, the size of that tax. Alternatively, if we were to subsidize hot dogs, and let's maybe use green to subsidize hot dogs. If we were to subsidize hot dogs, and again, that subsidy were to be paid to the supplier, the subsidy would just shift that to the right. And that is, in this case here again, the size of that subsidy as to how big it is would be just again that vertical distance between the original supply and the new supply. Oh, that's not quite where it is. Let's try that again. There we go. That vertical distance, that shift, that is going to be the size of the subsidy. That is how much we are subsidizing each hot dog. And if you were to bring that over to our price or our dollars axis, we could see what is the subsidy per hot dog. And in this case, maybe we're subsidizing 25 cents per hot dog. That is, you as the consumer go and buy a hot dog, and you actually have to pay 25 cents less than what the firm actually receives. Where does the firm get that extra 25 cents from? Well, the firm gets it from the government through that subsidy. So taxes, subsidies just shift that curve left or right, such that the magnitude of the shift is just the size of that tax, the size of that subsidy per unit. And that's the final determinant for our supply side. From here, let's bring together our supply and demand curves. As we bring them together, we'll introduce this idea of equilibrium. We'll talk about why it's an equilibrium, as well as talk about the impacts that profit has on this as entry-exit conditions for the number of competitive firms in this equilibrium. So let's go evaluate that next. Okay, so what I've done here is I've brought together our supply and our demand diagram. I'm just carrying forward the representative equations that we've used for our supply and demand for, what have we been talking about? We've been talking about hot dogs. So, as we take a look at this supply and demand for hot dogs, what we get is we get where the two intersect each other. That is where supply equals demand, or where our quantity supplied equals our quantity demanded. And that gives us not only our equilibrium quantity exchanged, but it also yields for us our market clearing price. Okay, I could wave my hands and I could say, hey, yes, this is an equilibrium. In order for this to actually be an equilibrium, though, there must be market forces to make this stable, to make this kind of, going back to our game theory language, a Nash equilibrium, a place where we don't have any incentive to leave. And in order to evaluate that, let's take a look at a situation where we're not in equilibrium and why we would want to get back here. To start off, let's change the color to red here, and let's start by saying we have a low price. So that is, we have some price in this market that is below equilibrium. Well, if we have some price below equilibrium, again, let's just keep the consistency of the red. We would have that low price. At that low price, the price to our supply curve would yield our quantity supplied. That price to our demand curve would yield our quantity demanded. So we have our quantity supplied, we have our quantity demanded, and what we see is that at this current price, we have all of this excess, there we go, demand. That is, we want a lot more than is currently being produced. To give it some values, we could figure this out, right? So here, off of our demand curve, let's say this is a price of, well, let's say, I don't know if that's 2. Let's say this is 210. Okay, what would we get? So, based off of our demand, that is 210 equals 10 minus 0.5 Q. We can solve for our total quantity demanded in this case here. So let's just go through that process. Move it over. We would have 0.5 Q equal 10 minus 210. 10 minus 210, that is 790. So 790 equals 0.5 Q. Divide both sides by 0.5. And that's going to give us altogether that our quantity demanded is going to be 790. That's going to be, if my mental math is right. Somebody can correct me in the comments if it's not. I'm getting something like 1580 as our quantity demanded. If that's not exactly correct, please correct me, but it's not going to be the end of the world for our example. So the idea is to figure out roughly what our quantity demanded is at this price of 210. Okay, alternatively, we can go through and we can say, well, what is our quantity supply? Well, again, our quantity supplied, our supply is price. Well, price was 210 equals, go up to our supply side, 2 plus 2Q. So, okay, let's subtract 2 from both sides. We get 10 cents equal 2Q. That's our quantity supplied. Divide both sides by 2, and we get 0.05 equals our quantities supplied. So 0.05. Again, if we were to think about these quantities in thousands, that makes a little bit more sense. That is, we would only be willing to produce around 50 hot dogs, but we would want 15,800 hot dogs. We have a lot of demand for hot dogs versus what the firms are willing to actually supply at this price. This can be problematic because you really want the hot dog, but the hot dog is not available. So in these cases, wherever we have a discrepancy between the quantity supplied and quantity demanded, it is typically the lesser of the two, which becomes our quantity exchanged. Because it doesn't matter if people want 15.8 thousand hot dogs, we're only making 0.05 thousand hot dogs. So too bad, most of you are out of luck. But what begins to happen? These people really want their hot dogs. So if they really want their hot dogs, what are they doing? They're willing to pay more. They're willing to outbid each other in order to ensure that they get the hot dog. The firm, seeing this opportunity to collect this economic rent, says, hey, we could increase our production. Yes, as we increase our production, we have to charge a higher price, but people are already willing to resell our hot dogs on a secondary market for a higher price in order to ensure that they get hot dogs. So what if we just sell at this higher price? And the result of that is that we begin to get a higher price of hot dogs. We begin to supply more, we begin to demand less, and still have excess demand, so we still push up the price. Still have excess demand, push up the price. This whole process continues until our price is such that our quantity supplied equals our quantity demanded. That is, we are producing the right amount of hot dogs based off of the amount of hot dogs being demanded at that price, and we no longer have an incentive to push that price up any higher. So in this case here, the demand, the excess demand, the demanders begin to bid up the price. The suppliers just respond to the fact that people are willing to pay more, and they begin to produce more. So in this case of excess demand, the demanders push up the price, the suppliers take advantage of this economic rent and begin to increase their supply. Altogether, this results in higher prices and a migration to our quantity exchange such that quantity supplied equals quantity demanded at the market clearing price. So that's our story for a low price. What happens if we have a really high price? Well, let's go take a look at that. Okay, so in this scenario, let's suppose that we have some price that is higher than that market clearing price. And the result is take that high price, drag it across, and we get where that high price equals our demand curve, our total quantities being demanded, and where it hits our high curve, well, that is where we get our total quantities supplied. So price high to demand yields our quantity demanded. Price high to our supply gives us our total quantity supplied. In this case, what do we get? We get all of this excess supply. Again, I could put some notional value for that high price and solve for what that quantity demanded, what that quantity supplied would be, and figure out what the value of our excess supply is. But we kind of just saw that example. We don't need to beat the dead horse. It's just the algebraic input, get the result. Similarly, because we have this discrepancy, doesn't matter that the firms are making, I don't know, 14 hot dogs. People only want to buy 2 hot dogs at this high price. So, and I just made up those numbers. I don't know what they are. But let's just say, doesn't matter if they're making 14,000 hot dogs. We only want to buy 2,000 hot dogs at this high price. So, although we have this discrepancy, again, the lower of the two becomes our quantity exchanged at this high price. In this case, we have to remember why firms are in business. And that is, the firms are in business, these hot dog makers are in business not because they love hot dogs. It's not that they just love making hot dogs. No. They're making hot dogs to sell these hot dogs to maximize their profit. If they are making all of these extra hot dogs, that's not great. These hot dogs are going to start to go bad. They're going to start to soil. They're going to start to stink. Most importantly, they're not going to be making money off of these hot dogs. That's not good from a profit maximizing point of view. So they could let them rot. They could let them go bad and make no money off of them. Or what the firms could do is they could start to lower the price of their hot dogs, put them on clearance, put them on sale so that people buy them before they go bad. And if the price goes down, people go, hey, at a lower price, I'm willing to buy more hot dogs, move along our demand curve. The result of that is at a lower price, we have, okay, next round of production will produce fewer hot dogs at that lower price, but people will want to buy more hot dogs than they did before. In this scenario, we still have this excess supply. We're still making more hot dogs than people want to buy. This is problematic. The hot dogs will start to stink. So what do? We put them on clearance. We learn from that mistake, And we have a new lower price, lower levels of production, lower price, lower levels of production until we get at some market clearing price such that our quantity supplied equals our quantity demanded. And we are now completely selling all these hot dogs that we are producing in this period of time. We no longer have excess supply. We no longer have excess demand. We have found a market clearing price such that those two are equal, and thus, again, we are at equilibrium. So in this case here, excess supply, it is the supplier who begins to push down the price. In the previous case, excess demand, it is the demander who begins to bid up the price. In each case, whenever we have excess one or the other, there's an incentive to change the price, which then changes our quantities until we arrive at the market clearing price such that quantity supplied equals quantity demanded. Okay, with that idea of equilibrium in place, let's go and see how we actually solve for this equilibrium and compute what is the equilibrium for this market of hot dogs that I've just created. Let's go take a look at that. Okay, what we can see is that where supply equals demand, where we get quantity supplied equals quantity demanded, well, that's the same point where the price from our supply curve equals the price from our demand curve, or our maximum willingness to pay is the same as our minimum willingness to accept, or our marginal cost equals our marginal benefit. That is, we can find what these values of P and Q are just by setting our marginal cost equal to our marginal benefit, our minimum willingness to accept equal to our maximum willingness to pay. So let's go do that. What we get is our marginal cost of 2 plus 2Q is equal to our marginal benefit of 10 minus 0.5Q. And again, we can just keep them as Q. Yes, this is quantity supplied. This is quantity demanded. But at this equilibrium, they're both the same. They're just Q prime. So Q is common to both sides. Let's consolidate and then isolate. Myself, I don't like negatives. So let's move this negative 0.5Q over to the left. We get 2 plus, that's going to be 2.5Q, and that's going to equal 10. That gives us 2.5Q equals 8. Continue to isolate our Q. What do we get? Divide both sides by 2.5, and we get that Q, our equilibrium, such that quantity supplied equals quantity demanded. 8 divided by 2.5, that gives us 3.2 as our quantity. So if these were thousands, that would be 3,200 hot dogs. 3.2, that is our quantity exchanged of hot dogs. How do we figure out our market clearing price? Well, that's where our marginal cost equals our marginal benefit. That's where our minimum willingness to accept equals our maximum willingness to pay. So we should be able to find it by taking this 3.2 and plugging it in to either equation. Let's plug it into both to make sure we haven't made any mistakes. So marginal cost, or minimum willingness to accept, 2 plus 2 times 3.2. So 3.2 times 2, that's going to be 6.4. 2 plus 6.4, that's going to be a price of $8.4. So we get a market clearing price of $8.40 to sell 3,200 hot dogs. To confirm, we should get the same answer if we use our maximum willingness to pay. We get a price that is equal to 10 minus 0.5, 3.2. And so if we use that, well, what's half of that? That's going to be 1.6. So 10 minus 1.6 is a price of 8.4. So we get our minimum willingness to accept, or our marginal cost of $8.4, and we see that that is one and the same as our maximum willingness to pay, or our marginal benefit from that last hot dog at $8.4. So we've just solved for our equilibrium such that we have our market clearing price of $8.40, resulting in 3,200 or 3.2 hot dogs being bought and sold. Okay, that does us for this video, which does the brief, quick overview of our supply, our demand, where each of those curves came from, as well as bringing them together, the determinants of each, and the idea of equilibrium. In the follow-up videos in this series for this topic, we will be looking at surplus, that is our gains from trade. We will be taking a look at what's known as comparative statics, which is what happens as some of those determinants begin to change. And then we'll be taking a look at this note of surplus as to what happens if we have market power. This surplus is this idea of allocative efficiency and the impact of what happens with collusion if firms start to collude with each other to form cartels. In the other video that will be out, we'll take a look at if government gets involved with some policies. What happens if government starts putting in price controls, things like price floors, price ceilings, quotas on production, or they start putting in taxes and subsidies. And we'll take a look at what impact that has onto the efficiency of the market, as well as that other term I introduced that I said we'll take a look at in the other video, which was this idea of surplus. So 2 more videos taking a look at 2 more aspects with this idea of our competitive markets. If you had any questions on this one, please feel free to leave a comment or shoot me an email. Until next time.